Okay, so let's talk about graphing polar equations. Now, remember that polar equations, the points in polar are basically r comma theta, where r is the distance to the origin, theta is the angle, that's the standard position, but r is dependent on theta. So whenever we go to make a t-chart for like points to put on a graph, you're going to be plugging in thetas and getting back r's, even though the points are reversed in that order. So whenever we're making a polar graph, the idea is you're plugging in values for theta and getting back values of r. Now, you could be like extensive with this and plug in every single value on the unit circle to get all the points that fall on a graph. There is a faster way of doing this though, and that is to think about quadrantal angles. So if I start with the theta being, say, 0 in this equation, the cosine of 0 is 1. 2 times 1 is 2, plus 3 is 5. So when my angle is 0, my r is going to be 5. So at angle 0, my radius is 5. Now, when I go to my next quadrantal angle, which will be pi over 2, cosine of pi over 2 is 0. 2 times 0 is 0, plus 3 is 3. So at pi over 2, which is 90 degrees, my radius is 3. Now, between those two, my angle increased from 0 to pi over 2, and as it did so, my r got consistently smaller. So what I'm going to do is draw a curve that connects these 2 points where my radius, my distance to the origin, is getting consistently smaller. Now, if you didn't feel comfortable that that was accurate, you could plug in numbers in between 0 and pi over 2, pi over 3, pi over 6, pi over 4, and plot those points. But most of the time, we are looking to sketch polar graphs, not draw exact ones. All right, so let's move on to pi. Cosine of pi is -1. 2 times -1 is -2, plus 3 is 1. So your radius at pi, distance to the origin at pi, is going to be 1. Now again, as the angle increases here, the radius is going to decrease, resulting in a graph that curves inward as you go around. So now we're going to plug in the next quadrantal angle, which is 3 pi over 2. Cosine of 3 pi over 2 is again 0, so my r is going to end up being 3 again. So at 3 pi over 2, my radius is going to be 3. Now, we want to draw this connected as well. So we got this, it came through here, now we're going to come down here. Again, it's going to be curved inward. And then we go back to 2 pi, which is the same value at 0, which is 5. Now, is this the best graph? Is it a perfect graph? Absolutely not. What could I do to make it more accurate? I could plug in angles in between these in order to actually get the graphs themselves. What I'm looking for is for you to understand where the graphs come from, not necessarily, and how to generate a quick, super quick sketch in case you need it, not to get a fully accurate graph.